Hello again. Thanks for watching this video and studying your math with me. Today's topic is division of algebraic expressions, and there are two kinds of division we'll be doing. One in which we're dividing by monomials, one term, and one when we're dividing by polynomials with more than one term. As always, you should read your book. The examples there are different, and you should start and stop this video to ensure you understand the material. If the denominator is a monomial, simply divide each term in the numerator by the denominator and simplify. Here's an example of that kind of a problem. Pause the video, work the problem, and we'll see how you do. Let's see how you did. When we do the exponents first, we get an expression that looks like that. These are not like terms, so they stand alone. This monomial in the denominator is divided into each term in the numerator, and at the end of the division, this is what you should get for your answer. If you divide a polynomial by another polynomial, it's more complicated, but it's very similar to division, to long division using numbers. So we're going to review that. If we were to divide 3875 by 25, we would arrange it this way. 25 will go into 38 one time. We'll multiply around to get 25. We will subtract it and bring down the next number. 25 will go into 137 five times. We multiply around, get 125. We subtract, bring down the 5, and again it will go 5. So the answer is 155, and there is no remainder. If, however, we had started with a dividend, which is what this one is called, of 3879, it would be much the same until the end, but when we subtract, we would get 4. 25 is not going into 4, so we will write the remainder as the remainder, which is 4, divided by the divisor, which is 25. You will see that we do the same kind of thing, only with polynomials. Here's a first example. Give it a go and pause the video and we'll see how you did. Let's see how you did. So 3x will go into 3x cubed, x squared times. So when I take x squared times minus 2, I get minus 2x squared. And x squared times 3x cubed is this, and we will again subtract. Now when we subtract 19 minus a minus 2, we will get 21x squared, and this cancels out by design, and we will bring down the 13x. Now we will ask the question, how many times does 3x go into 21x squared? The answer is 7x. 7x times minus 2 is minus 14x. And 7x times 3x is 21x squared. We will subtract, getting 27x, and again now we will bring down the minus 20. Then we ask ourselves, how many times does 3x go into 27x? The answer is 9. We will multiply around, we'll get minus 18, and 9 times that is 27. We will subtract. When you subtract, you change the sign of the bottom number and add, and we will get minus 2. Now 3x will not go into minus 2, so that is written as this remainder. It is minus 2 over 3x minus 2. That is how you should answer the question. The last example has the feature where you need to insert some zeros as placeholders. This will keep you from getting confused. So d will go into d cubed, d squared times. But then when I multiply around, I will have d squared times minus 1 is minus 1d squared. When I subtract that from 0, I get d squared, and I bring down the 0 d. Now I ask myself, how many times does d go into d squared? The answer is d. So I multiply around, subtract again, and bring this down, and you see I get a 0 remainder. The answer is going to just be the quotient. It is d squared plus d plus 1. In closing, remember that time is precious. Each day must count. Do the math. It will make you strong. Take care, and I'll see you in class.